Okay, welcome to our, I don't know what week this is, but we're a long way into the course. I think this is week at 10 or 11. Um, so glad you all made it back. No one decided to run away after the midterm. That's always a good thing. So what we'll do first, as soon as I can figure out my computer here. No, we don't want that yet. Go away. Oh. All right. So we are going to review the midterm. And what I'm going to do, I'm not going to go through all 50 questions because y'all actually did pretty well. So the high for the class was 96%, the low was 79.5, the average was actually 87. So that's pretty high and in the scope of things. So you, as I said, you should be really proud of yourselves. Overall, you did pretty well. There is a few questions that were questionable, and I'm going to review them. Number 9 was one, and I'm going to use, I know it's not fair, you weren't able to use the developer, but I'm going to prove the answers because I will give you the opportunity to challenge any of the questions. Now, you have to be pretty confident that either I'm just ridiculous in my wordy questions and answers, but I'm going to show you where I arrived with the answers. So we're going to start with number 9. And basically you were given, you attempt this query and you get an error. So where is the error? Which clause contains a syntax error? And before I run it, many of you chose a select clause. I'm not sure why. Can anyone explain why the select clause it would cause an error?
I
Because
could,
of the job
I
as
could,
job.
sorry.
Oh, go ahead, man.
No, I could kind of explain because I think I got this one right. I'm pretty sure I got this one right, but
All
it
right.
did throw me for a loop, and I can see why the confusion because it's where I got confused initially as well. And that is because where the error is a little bit, it's linked a little bit because at least this is where I got confused. It was that last order by.
Right.
Well, not that was order by, but where it said dates hired, I'm pretty sure.
Yeah, no.
It was a different case. So
So,
I think the reason why people thought it was wrong was because the different cases
all right. So, and
and
that doesn't matter. Well, it does, but it doesn't.
mhm.
All right. So,
This is where I got.
first of all, to address Richard's, you can have an alias that's one word, and it does not have to be enclosed with double quotes.
Mhm.
So that's why that part is not an error. And I'll show you this. And the key here is that with the order by clause, you cannot use an alias. And we went over that in one of the lectures. So if you run this in developer, it will actually tell you where the error is. So I'm going to run this, and it says date hired, invalid identifier, because it's an alias. You cannot order by an alias of a column. And as you see, job is fine. As long as you have one word, the system will recognize it as a valid alias. Now, if you were to change this to the actual column name, it's hired. What's the column name? Hired date? No, that column name is wrong. Maybe that's what threw you all. Oh, it is hired date. So if you change that to the actual column, then yes, it gives you at least a response, where the department is null. So Grant doesn't have a department. So all the rest of the query is fine, except for you cannot order by an alias. All right. So that's why that part of the clause was incorrect. All right, now the next question that was highly missed was number 13. And 13, referencing the employees table. So you had to put on your memory hat, but it really doesn't matter. You should be able to figure this out. Which query would display employee ID, last name, and their manager ID if an employee does not have a manager, display no manager? Do we all remember that particular handling nulls query? Who wants to because this was missed. This was probably the most missed. And I think only four of you out of the
Isn't
11
it
of you discussed it.
option 3? Because the NVL changes the null to a string, but there's no reason to put the to char in there because we're not changing anything to characters, essentially.
Absolutely. Everyone hear that? Basically, if it sees a null, it's just going to replace it with no manager. So, and you don't have to do a to char or anything like that. Any type of character change function or anything like that. So, yes, it is number 3. So if you run that, oh, maybe it's not number 3. What did I do wrong there? NVL manager, no manager. Maybe this one is more of a tricky one than I thought. Oops. Maybe this one I may end up giving you credit for. Let's see. No, there's really no need to do that. Oh, what is manager ID? That is
Yeah, I was
Manager-
actually gonna
manager ID is a number, right?
Oh, yeah.
Yeah.
Okay. Yep.
So in order to replace a data type with another data type, you do have to do a to char.
Well,
yeah, that's what I was thinking because I think I got that one right, and I remember it being MBO to chair because manager ID was a number, so that's not a character,
But-
like a string.
but if there's no manager ID, wouldn't it just be null? Which
No,
isn't.
but the data type for that column is still
Yeah.
it's
Got it.
still a
Okay.
number. It doesn't matter whether it's even though null is not a value, the data type is number. Manager ID. So that's why you have to do a to char. Does that make sense to everyone?
Yeah.
Okay. That's why the other one did not work because we're trying to replace one data type with another. All right. I know you're all getting ready to challenge that question, right? I wouldn't blame you.
Well,
All right.
that makes sense now that you explain it.
I'm
Yeah,
pretty sure I picked the MBO to chair, and I think in the test it said it was correct, but I can't remember.
it did say it was correct.
Yeah, because I was about to say, wait, I got that one right picking the bottom one, so if the third one is right.
Yep. All right. The next one that was questionable or had many misses is number 21. And what would the following SQL query return? This one was kind of tricky. Select count first name from employees. Now, most everyone that missed it jumped on the total number of rows in the employee table. That's not necessarily correct. Why is that not correct?
Because we have the first name clause in there.
Yeah, so what if and I think there's a couple of first names that are the same. So it's going to list all the unique first names in the employees table or the total number of non-null first names. So which one, A or C?
A.
A.
All right. So it doesn't have anything to do with unique because we don't have what would we use to get at unique names?
Distinct.
Right. So it's going to list all the number of non-null. So it may list all the rows, but that's still the most correct answer is, yeah, the first one. And I will show you what happens when we run this query, just so everyone. We had less people miss this one, so yes, there's 20 first names and there's 20 rows. And you can argue, if you want to challenge this, that is the number of rows in the employees table, the total number of rows. So this would be one. If you missed it, you could possibly challenge it. And if I'm feeling graceful, I would give you credit for that if you want to, because there's 20 rows, but the more correct answer is the total number of non-null first names in it. So, all right. Okay, the next one that was Miss Hiley. Does anyone want to challenge that one? Speak now, or you can send me a message if you don't want to, let the whole class know. Right. Next one was 25. All right, what function can be used in a select query or select statement or select clause to display a date in the format listed below there? And most of you jumped all over that to date. And remember, format is a conversion. So you're converting it to not necessarily, you're just converting it to a format rather than just a date, even though the system will recognize it as a date. So yes, it's going to be to char. That's your conversion. So remember that. I know a lot of you chose to date, and that's incorrect. All right, and then the last one that was a little bit of a problematic question. And I was really surprised. Most of you all got all the questions right after 25, which is the first time I think I've had that the case. I think most students get tired after question 30, and then you just want to mark whatever. So the last one that was Miss Hiley was 37. Which of the following select queries will return the last name and commission of each employee if they have no values in the commission, will return the string no commission. So this is kind of the same thing, right? As the other question that everyone missed. So we're basically, it's a handling null scenario. So which one of these is the correct? Now remember, commission is what? Data type.
String.
No, the column commission is not a string.
Oh, so sorry. I thought you were talking about the no commission. No, yeah, no, that's a number. Commission.
All right.
Picked.
So what would you
Percentage is a
do
number.
to replace that with the, which one, A, B, C, or D?
D.
So these are pretty much incorrect in their syntax. And that's what none of these are correct.
Mhm.
B is kind of, but commission percentage, once again, is a number. No commission is a string. So basically you have to char the whole scenario to get that response. So D, if you read through these carefully, and yes, remember it's single quotes. So yeah, both the double quote one is a syntax issue. So just to show you. Or, yeah, that's a copy paste issue. Those single quotes are not going to be right. Oh, and this double quotes aren't going to be right. Hence, copy paste can be a problem if you don't get the right pronunciation. You know what I'm trying to say. Pronunciation. So yes. So you're using NVL. It's a nested function, and you're making sure both are strings, and hence the to char for both. To char for commission percentage, and then no commission, and hence there we go. All right. And other than that, as I said, y'all did pretty well. Once again, the high was 96%, the low was 79.5. And yes, there was one you're probably wondering whether the 0.5 come from, or actually 79.25. There was one question where it was a multi-select, and I think it was if I remember correctly, it was set operator or not set operators. Was it set? Well, anyway, the union all, minus, and intersect. They were all what do we call those? Well, anyway, yes, they were all correct. And so if you miss, then check one, you got 3/4 of a point or half or whatever. All right. So that was the midterm, and I'm pretty happy. You all should be pretty happy. No one really bombed it. So we will move on, or unless there's any questions or any challenges or any, if you're curious about any of this. Nope. You seem to be okay. All right, let's move on. Now we're up to module 9. So I guess we're in week 10 now, and then week 11 if you had the spring break. And we're going to talk about subqueries. You're all looking forward to this, right? All right. So our objectives: define and explain the purpose, construct and execute a single role. So in the where clause, and distinguish between a single role and a multiple role subquery. Okay, and our regular great reasons why we want to learn this. Has a friend asked you to go to the movie before you can go, or before you can answer yes or no, you first need to know if you have enough money, or I'm pretty sure you don't have to ask your parents. Well, maybe some of you do, but hopefully you don't. Hopefully you're not living with mom and dad. You can just go to the movie when you want to, but I never know. I'm not going to assume. So has someone asked you to answer the answer to a math question, but before you can give the answer, you had to do the problem yourself? Yeah, I've been in that boat. Asking parents or doing the math problems are examples of subqueries. And so basically there's a criteria that has to occur before you move on and answer a question. Hence, that's the whole purpose of a subquery. So the subquery executes to find the information you don't know. The outer query uses, and I'll show you what I mean by outer and inner query. It uses the information to find out what you need to know. Being able to combine two queries into one can be very useful, and yes, it can be. Subqueries and joins are probably the most complex as far as getting into the level of SQL that I've used when I was a database administrator. So it can be useful, and they can be substituted for each other depending upon what the scenario is. So just keep that in mind. One does not replace the other. One may be easier to understand, but and you'll see why when we get to some of the examples. A subquery is a select statement that is embedded in another clause or in a clause of another select statement. So yeah, that sounds confusing. I think I'm confusing myself, but hang in there. I will get to clarify the explanation. The subquery executes once before the main query. The result of the subquery, which the one thing that I will suggest or recommend, if you have any questions about a subquery, it is just another query. And in your SQL developer, you can always highlight the subquery to make sure you actually get a result. And you'll see that on some of the examples. Subqueries can be placed in a number of SQL clauses, including where, having, and from. And you're like, whoa, this is starting to sound a little complicated, but hang in there. All right, let's look at the syntax. So select, and you have a select list of columns or whatever from your table where the expression, you have some type of an expression equal to or whatever, and then you can throw a subquery in there where select. So it's a query in the where clause where the condition of the outer query is based on whatever you receive from the inner query. And usually you want to use a subquery when you don't know what to expect and you need that, the result of the outer query to be determined by the success of the inner query. Subquery, as far as the criteria and guidelines, subquery in SQL and this version of SQL has to be enclosed in parentheses. It's placed on the right side of comparison. And what I mean, if you have equal where a column is equal to, and then your subquery is there, not on the left side. And if you think about it, it doesn't really make sense to put it on the left side. The outer inner queries can get data from different tables, and hence that's where it's like or very similar to a join. Only one order by clause can be used for the select statement and has to be in the outer query. And that makes sense. You don't want to order your inner query because that may, well, it may cause issues with the outer query. And I'll remind you, when I say inner is usually the query that's, the kind of subsequent or the query that the outer query or main query depends on. You can only have one order by, and that's usually in the outer query. And there's no limit. Now, with the resources in these development engines, I would always limit myself to just three subqueries in one query. There truly isn't, there's no limit. And basically the resources in these query engines or development engines are basically that there's not any way that you can ping or create something that would cause a resource issue. All right. So there are two types of subqueries. There's a single row, and they use single row operators. You're greater than, equal to, less than, greater than or equal to, not equal to, and so forth. And they return only one row from the inner query. So remember that, just one row. That's a single row. Kind of makes sense. And then there's multiple row subqueries that are used in multiple row operators like in, any, and all. And I'll give you an example of those. Yeah, I think you've seen in. Any and all are very similar as far as the operators. And it generally return more than one row. Hence the term multiple row query. Isn't that pretty catchy? All right. So what if you wanted to find out the names of the employees that were hired after Peter Vargas? Of course you could just, query the table and see the order by dates and say, oh, I see. But let's say we have more than 20 employees. Let's say we have 1,000 employees, and we're going to give, well, the criteria is a little bit different. So the first thing you need to know is the answer, when was Peter Vargas hired? Once you know this hire date, then you can select those employees whose hire date is after his. So the query would look something like this. Select first name, last name, hire date from employees where hire date is greater than, and so select hire date from employees where last name is equal to Vargas. And you see how that works? So I would suggest if you want to make sure this inner query produces a result, that's always a good way to check your sub query. So inner query, outer query. The outer query is dependent upon a successful result of the inner query. See, we got Zotke, Grant, Morgos, and Lorentz. All right. Now, if a subquery returns a null value or no rows, you'll get a no data found. Basically, and be careful when you do this. If you get this result, it's either something wrong with your inner query, or literally there's no data. Which I would wonder, why would you build a subquery to get no data? So remember that. I would, once again, and I'll say this several times, test that inner query before you even run. You can do that. And I will show you here at the end. Basically, you're just highlighting an inner query and making sure you get a results. All right. Quick. So, so our terminology in this very quick session, subquery, inner query, outer query, single row subquery, and multiple row subquery. Pretty straightforward. Any questions? All right. On to section 2, single row, going to detail or extract or expand the whole idea of single row subqueries, why it's used. And I will definitely show you a few examples. So our objectives are these. Basically, we're going to construct one with the where clause or having clause. Hopefully you remember why you used each of these clauses. There's a reason. Construct and execute a select statement using more than one subqueries. Construct and execute select statement using a group function. And now I'm throwing a kind of a little curve here to some degree, but it really isn't. All right. So as you probably realize, subqueries are a lot like internet search engines. Yeah, whatever. They are great at locating the information needed to accomplish another task. So basically, if you don't know something, then you would use a subquery to accomplish that. So we're going to learn how to create even more complicated. Now, that's a relative and subjective term. That will do this for you. Keep in mind, subqueries save time, that you can accomplish the task in many ways. All right. Some facts about single row subqueries. They return only one row. Yeah. So return only one row. Wrap your head around that. Use single row comparison operators, and I went over them before. And you've seen these before. Always enclose it in parentheses, place the subquery to the right side. So we saw those guidelines. That's just another reiteration. And some more reiterations, different tables, only one order by. Yeah, and this is kind of repetitive, but just wanted to make sure you are aware of that. All right, here's an example of our first single row subquery. So who works in the marketing department? So basically we need last name, job ID, department ID, where department ID is, and basically we're using two tables here, the departments table and employees table, and we know that Hartstein and Fay, the marketing manager and the marketing rep, work in department ID, which is the marketing department. Ooh, pretty catchy, huh? All right. Let's look at more than one subqueries. Yes, you can do this if you're looking. So once again, this query looks very complicated, but it's just a good way because you have two unknowns. We want to know basically who works the same job as employee ID 141, and they're in department 1500. So our first subquery is select job ID from employees, where employee ID is 141, and that's the job ID, this particular individual. And of course, excuse me, you could simplify this quite a bit, but this is used to illustrate an example that you can use more than one subquery in your select statement or any SQL statement. So as you see, the result of the first subquery is the job ID is job clerk. So yes, you can simply substitute, stock clerk or ST clerk and the department ID. And basically we're wondering what the department's at location 1500 if we did not know that. So there you go. So we have all these individuals that are stock clerks that work at this location, right? And please notice the syntax of this, how it's nice and neat, and you can read through this, and yes, you can highlight any of the subqueries and make sure you get a response. Once again, I would definitely check that as you're running these subqueries because it can become a little confusing. Okay, group functions and subqueries. Yes, you can use subqueries and group functions. You're probably wondering about that. So a group function without a group by clause and a subquery returns a single row. The query on the next slide answers the question, which employees can earn less than the average salary? So that's a group function, right? So select last name salary from employees where salary is less than, and select the average. So the average salary from this query comes back 8,775. So basically you will get a row for each, well, a return for each row. Now this is a group function. You're saying, well, that's multiple rows. Well, not really, because the subquery here returns this single row, right? Does everyone see that? And yes, it's a group function, but that's the result of your subquery. This is the result of your main query. Please remember that. And this is a group function as well. So that can be a little confusing when it comes to group functions, but remember what you're expecting in a group function anyway. You are expecting one row from this query anyway, correct? All right. Does everyone get that? Does that make sense to everyone?
Yeah.
Pretty straightforward. All right. Remember, using the having clause, that's basically the purpose of that is to filter groups, right? So subqueries can also be placed in the having clause. So remember, the having clause is similar to the where clause, except the having clause is used to restrict groups. Just said that. So when you use functions like min, max, average, as we saw before, and because the having clause always includes a group function, the subquery will nearly always include a group function as well, and that makes sense. So which departments, the question here that we're answering is which departments have the lowest salary that is greater than the lowest salary in Department 50. You're talking about a complex scenario. So in this example, the subquery selects and returns the lowest salary in Department 50, and then your main query goes, so you may not know the lowest salary. So select Department ID, minimum salary from employees, group by Department ID, right? Having, remember, filtering out minimum salary less than, and then you select the minimum salary from employees where Department ID is 50. So these are the departments that have a minimum salary lower than the minimum salary of Department 50, which is 2,500. So that's the minimum salary. All right, that's greater than. I said that wrong. Now, all of this has been greater. I'm looking at the results and wait, that doesn't match what I just said. So, I read this wrong. Greater than the lowest salary. No one corrected me on that. So it's greater than 2,500, right? We get that? Phew. Quick recovery there. All right. All right. And just a reminder, remember having as the filtering mechanism to filter groups. We have a group by, and notice we have a group by here in our main query. And yes, it's just going to group by the single result return here, which is just going to be this 2,500. It logically makes sense if you look at subqueries, and I definitely would recommend make sure that you understand or using a subquery, and obviously run that subquery first to make sure you get the result expected. All right, on to section 3, multiple row subqueries. So our objectives correctly use the comparison operators and any and all, and I'll show you those. And construct and execute a multiple row subquery. In the where clause or having clause, same idea as before. Describe what happens if a multiple row subquery returns a null value. It does some ridiculous things. Understand when a multiple row subquery should be used and when it is safe to use a single row subquery. Probably in most scenarios, just to offer a suggestion, you probably want to use a single row because that will make more sense. If you think about it logically, it probably is cleaner and you don't really want to get that complicated. Results. I'm going to talk about pairwise, non-pairwise, just to let you know these particular terms are not used anymore. It's definitely old school, but Oracle wants you to learn them. And you can kind of get an idea of what pairwise and non-pairwise subqueries are. And then some other functions exist and not exist operators to test for return rows from a subquery. In my experience, if I can't get the subquery to run, then I know there's an issue and I don't normally want to use the exist or not exist, but I will show you how those work. All right, so let's see. The subquery is designed to find information you don't know so that you can find information you want to know. Pretty catchy. However, a single row subquery can return only one row. What if you need to find information based on several rows and several values? Yes, we can do that. The subquery we need to return several rows is referred to as a multiple row or multi-row subquery. And use these 3 comparison operators only. in, any, and all, you could probably determine what the, in a group, any in a group, and all of the group. There you go. All right. So our question, whose salary is equal to the salary of an employee in Department 20? Anyone in our little company. So in our example, this returns an error because more than one employee exists in Department 20 that the subquery, so the subquery is actually returning multiple rows, and we wrote a single row because we use what? We use that single row operator, right? Equal. So you get an error, single row, and you'll see this error a lot because you're thinking you're writing a multiple row and you're actually writing a single row. Error, because there's two individuals. So how do you solve this? I just pointed that out. Use the multiple row operators in, any, and all. And basically this allows for more than one value to be displayed or returned. So remember that the biggest difference in your single and multi-row is the operators. In, any, and all, the not operator can be used with any of these three. So the not, generally, logically, if you think about it, so you go not in, not any, not all, but then it becomes a little confusing because you're like, well, why did I do that? I can just use a different criteria. All right, here we go. So the in operator is used within the outer query where clauses select only those rows which are in a list of values. So for example, we're interested in all the employees that were hired the same year as an employee in Department 90. Hence our select statement, select last name, hire date from employees where we're using our extract function just to pull out the year, right? Years and then we're using a subquery, select extracting the year from our date, from a hire date, where the employees are the same year as the employees in Department 90. And we got 4 individuals that are returned. Now this query can be a little confusing. Remember, if you remember way back in these types of functions, you can extract a particular part of a date, extract, etc. Right? That's what we're performing here. So basically, we know that these the employees in Department 90 were hired in 87, 89, and 93, and so hence, I think these are all the employees in. Our table is a little abbreviated, so yeah. Do we understand the usefulness of the in operator, which is in a list? This is going to be a list of years, right? In the subquery. Do we all see that?
Mm-hmm.
All right. And I just went over that, and all right. So that's the end. Now the any operator is used when we want the outer query and the where clause to select the rows which match the criteria, kind of less than, greater than, equal, etc., or at least one value in a subquery result. So basically, any value in the inner query that's matched will return a result. That's why you get multiple. And yes, we can use, and this is a little confusing, we can use the single row operator less than any. So we're just asking anyone that's less than, and our example here, any employees whose year hired is less than at least 1 year hired of employees in department. So any date, less than any date. So this is once again a list of dates in that subquery. So anyone that's less than any date that's in the department ID. Why would you run this? Probably to confuse your boss. So the thing of it is, this is what is returned in that list, 87, 89, and 93. And so any employee that's less than any of these will be returned. Hence, is why we get Wayland, Keen, Kokar, Hunnell, and Ernst. Does that make sense? It's kind of a crazy scenario, but that's the use of it. Any, it's almost kind of like a wild card. You probably don't want to list create a report. It's almost like a haphazard way to create a report. Or maybe you're trying to impress your boss or something, but all right. Now all is a little bit different. So this one, you're trying to match all, and this, I use the same, essentially kind of the same query so that you can see where if there's any that match and it returns, if you use all as the term references, you have to match all the values. So this saying we need employees, an employee table that match all of the values that are less than all of the values. And of course, that query would not make any sense because everyone or no one's going to be less, right? This is the higher date. If you have some historical data or whatever, you can probably use that. But remember, all the conditions have to match. In my experience, I rarely use the all operate in a subquery because it really doesn't make sense. All right. So that's the end. Any all null values. Once again, you have to be very careful with nulls. It changes things a little bit. Suppose that one of the values returned by a multiple row subquery is null, but other values are not. So if any are used, the outer query will return rows which match the non-null values only. And maybe that's not what you want. So you have to be very careful. And my suggestion, if you're in a real life scenario, you want to account for nulls before you start doing any subqueries, because it's basically going to ignore the nulls, which may not satisfy your requirements. So if all is used, the outer query returns no rows, because obviously if you have a null, they don't match, right? Yeah, so be very careful with those and nulls. Nulls are always a kind of a problem. Okay, so moving away from those a little bit, as you might suspect, the group by clause and the having clause can also be used, obviously, in a multiple row. What if you wanted to find the departments whose minimum salary is less than the salary of any employees who works in the department 10 or 20? Here are basically our results. And where did I put the query? And if you look at the query, if you walk through this, so select department ID, minimum salary from employees, group by department ID, having minimum salary, remember, less than any, select salary from employees where department ID is in. So there's quite a few functions in here, but it all makes sense. So we want to return a table that looks like this, right? So here we are. Our inner query returns this, and anyone that matches that is returned in our outer query, which is this. Does everyone see that?
Yeah.
So it's less than, so it's a little, with our small database, it's a little confusing, but these, if you put, and we're grouping by the department, so since this null is not, we have one individual, which is King, who's not in the department, or Grant, who's not in the department. So he's, even though that null is not handled, it's just that individual is not, or that department has an individual that's not identified. Once again, handling null before you create a report like this would be beneficial. That's why we have that. We have all the departments and then that null department, or that individual that has no department. All right, multiple column subqueries. Yes, you can do this. So subqueries can use one or more columns. If they use more than one columns, they are called multiple column. Pretty catchy, right? Can either be pairwise, and this is where the pairwise and non-pairwise. So basically, without confusing you too much, whenever you have a pairwise comparison, basically your inner and outer queries as far as the columns, the inner query is always a subset of the outer query. So you're comparing just basically columns to columns. And that's basically when you're doing a multiple column, and you don't have to always be pairwise. And that's why this term can be very confusing. As you see in this query, select employee ID manager ID, department ID from employees where manager ID and department ID, or manager ID, department ID in, and then you give it basically, and if you really try to differentiate this, this is a very, very confusing query to be honest. You'll get an example of it, but you can obviously satisfy this in a very simple way without using subqueries or even having to understand pairwise. Just remember, a helpful hint: pairwise always has similar columns across the board, and if you have multiple columns, and that's the only time that you use pairwise or non-pairwise, and you'll have plenty of examples to experiment with that. Now, would you ever run a query like this? No, but it does give you an idea of how to compose a subquery if you wanted to do it this way with multiple columns. Excuse me. Yeah, I tried to simplify this query somewhat, but Oracle Academy says that you have to, illustrate this because of the outdated, antiquated terms, pairwise and non-pairwise. So to further, explain, it shows multiple column pairwise with the subquery highlighted in red and result in the table. Yeah, manager ID, employee ID, manager ID, department ID. And we have manager, so these two, manager ID, department ID, are known as pairwise because that's what we're looking for from our subquery to our outer query. And then the whole idea with manager ID, employee, what we're trying to accomplish with this is basically giving you the idea that, because you can have different tables and all that, right? We're using the same table. Now, yes, does this query make a lot of sense in a scenario? Probably not, but it does illustrate a pairwise scenario. All right. Now, non-pairwise, basically you separate. So all right. So non-pairwise multiple columns also uses more than one column, but you just separate. So manager ID in subquery, department ID in. So it's the same query. You see, it's the same result. This is pairwise. This is non-pairwise. Basically, that's the difference between the two. Now, once again, would you ever write a query like this? It's very nonsensical. It's probably useless in our little small schema scenario. So just to illustrate the difference between the two, this is separating the single columns so that they're non-pair, well, you can interpret that many different ways. But will you run across something like that in a true scenario? So one query per column, that's usually the differentiator. And this is the example of a multiple column non-pairwise subquery. And see the difference. Same exact query. So I will admit it's kind of useless, but I have to teach you that. All right. And I do show you the results of each of the subqueries. All right. I'm going to transition or segue right from that into the exist and not exist. And these are two clauses that can be used when testing for matches in subqueries. So if exists tests for a true or a matching result. So to answer the question, which employees are not managers, you first have to ask who are managers, right? So then ask who does not exist on the managers list. So interesting example. So you can run a query like this, selecting employees that are not managers, that are managers, excuse me. So select last name as not a manager for employees where not exists, and then basically all of these employees do not have a manager ID. So basically, these are the non-managers. So basically saying that these employees do not exist in a manager, in this list of managers, right? Does that make sense?
Mhm.
So obviously you can do that a different way, but and this is the explanation. Result of this query suggests that there are no employees who are also not managers. So all employees are managers which are already not, but which we already know is not true. So this is using the not in. And the difference between not exists and not in. Kind of illustrating why you would use the not exists. So to further explain, basically, and not in is very tricky, so which is why in our little schema, we already know that basically we do have managers in our little database. So null in the subquery result set will return an unknown, so once again, nulls are another way to trip up your data as far as results. I've rarely used a not criteria for one of the in, any, or all. So once again, beware of nulls when using in or not in, primarily not in. If you're unsure whether or not a subquery will include a null value, either eliminate the nulls, as we all know how to do, or run your query a different way, or use an is not null in your where clause. That will ensure that you will have legitimate values returned. All right. One last point about subqueries. Subqueries may return a single row or multiple rows, depending on the data. If even the slightest possibility exists of returning multiple rows, make sure you write a multiple row query. So here's an example: select first name, last name, job ID from employees with job ID. And so we're assuming that this is a single row. Select job ID from employees where last name is equal to Ernst. We know that that's going to be a single row. But what if there's another Ernst added to the database? That could present a problem, and I think that's what we're trying to illustrate here. If Bruce Ernst's wife was hired, then that will be a multiple row subquery, and we'd have to change our approach. So essentially now we have two Ernsts, and we would get not a multiple row if we ran a single row subquery. So in essence, we use the in or the multiple row, and now we will receive all of the Ernsts. This is job ID. We switched it up, but if we wanted to use last name, actually we're using job ID anyway. But what am I trying to illustrate here? So in essence, whenever there's a doubt, I guess that's the point here. Just write a multi-row subquery, or use one of the multi-row operators. And even if it's a single row, you'll get a result. Generally, you get an error if it returns more than one row and you've written a single row subquery. But so if in doubt, write a multiple row subquery. It won't hurt you. All right, that's the lesson here. All right, so our terminology for section 3: exists, not exist, pairwise, non-pairwise, and then operating those with your subquery. This is probably the least useful, but it is pertinent information that you may run into. Okay, one last section for this evening: correlated subqueries. You can probably identify what that is. So identify when correlated subqueries are needed and sometimes they're not needed. Construct and execute one and construct and execute name subqueries within the with clause, a new clause. So you might want to pay a little bit of attention here. All right, so sometimes we have to answer more than one question in one sentence. So your friend might ask you if you have enough money for the movie and popcorn and a drink, because it costs a lot now. I think the last time I went to the movie, I paid like $50 for everything, which is ridiculous because I've been around long enough. For $5 could take you and your date to the movie, but that's beside the point. So before you can answer your friend, you need to know the price of a ticket and popcorn and a drink. You also need to see how much money you have in your pocket or your wallet or on your card. So basically, it's more than just a yes or no question. So in business, we might get asked to produce a report of all employees earning more than average salary for their departments. So here, you first have to calculate the average salary for a department and then compare the salary for each employee to the average salary of the employee's department. And that's a realistic scenario. So in Oracle, we call these correlated subqueries. So correlated means working together in some type of sequence. So basically to perform correlate when you want to use correlated subqueries when the subquery references a column from a table referred to in the parent statement. So get candidate row from the outer query, execute inner query using candidate row. And this is kind of a interesting language to reference the correlated. It means that they're truly correlated. And subqueries are all usually correlated, but this, and you'll see when I show you the example. So in essence, this is going to evaluate your subquery for each role identified, which is why it's called correlated. It's kind of like a loop, as we see here. Get, execute, use, get, execute, use, until you satisfy the requirements of the query. All right. So the parent statement can be a select, update, or so it can be any of your DDL statements or DML statements. So here we go. Here's a pretty good example. To answer our question, whose salary is higher than the average salary of their department? So to answer this question, we need to write a correlated subqueries to do a role by role processing. And that's the key. It's going to process each role that satisfies the requirement to identify who has higher than the average salary. So select, and we're using aliases because we're doing kind of like a self-join, but it's similar to that, but we're using the same table to evaluate salaries using salary. And we're only using the one table. So select first name, last name, salary from employees where salary, and then we select our average from employees for the department ID. Basically, who has higher than the average salary in their department. All right. So each subquery is executed once for every role. So this is going to be multiple rows, right? In the auto query, and then in the query will execute. This is why it's called correlated for every role. And it will bring the result who has higher than the average salary for the department. Does that make sense to everyone? Questions? This can be a little confusing, but it is like a looping scenario because it sets that up because we identify it as a correlated subquery and not. It's kind of like a multiple role, but it's evaluating things based on all of the data in the table, which is a very small table. So in that sense, as it's listed here, the inner query is driven by the outer query. So this is going to return all of the employees, right? First name, last name, salary from employees, where salary is greater than, and then there's a condition here. So there's going to be several results, but then in the inner query, we're looking at the average salary, greater than the average salary for the department. And we're, in essence, doing kind of a join here, which makes it a correlated, because we're using that department ID on both sides. That's where it can get a little confusing. So I would run this to see what your results are, to make sure you understand how that's going to control. That's going to be controlled by all of these values being, or these records be returned by the main or our outer or parent query as it's referred to. Okay. All right. So that's correlated subqueries. I mean, you'll hopefully, please go through the examples. In the test queries, it'll make more sense after you run a couple of them. All right, so we're going to introduce you to a new clause. It's the with clause. So if you have to write a very complex query with joins and aggregations used many times, you can write the different parts of the statements as query blocks and then use those same queries. This is almost like programming in a select statement. And I'll show you what I'm trying to illustrate here. Oracle allows you to write named subqueries in one single statement as long as you start your statement with the keyword with. So the with clause retrieves the results of one or more query blocks and stores those results for the user who runs the query. All right, so the general syntax, it does improve performance and make things easier to read. And the syntax is with, and then you give it a name as subquery, just like it shows here. Subquery as subquery, select column, et cetera, from where. So basically you write the query for the following requirement: display a list of employees, last names that are not managers. That's our criteria that we're going to illustrate our with clause. So to construct this query, you first need to get a list of manager IDs from the employee table, and then return the name of the employees whose employee ID is not on the manager list. We just did that before. We can create a name subquery using the with clause to retrieve the manager ID from the employees table. Then the outer query will return the employees that do not appear on that list. And this is what this looks like. With managers, we're naming our subquery managers as to select distinct manager ID from employees where manager ID is not null. Straightforward. So now we have a subquery called managers. Does everyone see that? All right, so then we can write a query select last name as not a manager from employees where employee ID not in our little managers. So we saw this result before. All employees, this does match what we had before. These are all employees that are not managers. And so we can run that anytime that we want if we have some scenario where we're looking for a result or a subquery that's used in this scenario for employees that are not managers. And that's the usefulness of a with clause. In big data sets, yes, you can save so much time using this simple development of a subquery. Does that make sense to everyone? I think you'll have a chance to run quite a few examples on that. And after you create the subquery, it remains until you close the session or delete it. So, all right, our last section, terminology, correlated subqueries. Remember, that's processing the little looping action and the with clause. All right, wow, that went pretty fast. Okay, let's take a look at, now that we've all recovered from the midterm, we don't need to review that anymore. Is everyone in class? Yes. Let me make sure I get the attendance down right quick before I review our requirements for the week. Yes, we are now in module 9. 9 out of 14. See, 9 out of 14. Coming down the wire. All right. Everyone is present and accounted for. All right. All right. So subqueries, our lecture will go there. There's some very good videos that hopefully will not put you to sleep. I know they all put me to sleep. Some of them are pretty interesting. And review those, especially the any and all. That one can be useful. And then the practice, and then some additional resources, a pictorial way of looking at these particular operators, all, And you go through these, you're like, oh, that makes a lot more sense than what the professor said. I can just follow this, which is fine. So just go through these. They're fun and they're colorful. And even they exist, not exist, why we need them, why they're in place. Gives nice, good examples, just something to reference. And then our practice queries, there's a lot of them. As we have 4 sections, go through those, pick out the ones that you have trouble with. It's always useful to run through these. They definitely help you to learn some of these particular additional SQL practices. And I do have pulling right from Oracle. There's a whole section on correlated subqueries that I definitely recommend you go through. It uses actually the same schema that you're looking at, but go through this because I buzz through this whole get, execute, use and how it works. This will explain it in detail, and there's a little video on it too. But please do that. That'll definitely be helpful with the correlated subqueries. Lots of resources, and then the practice and solutions for each set, always useful. And I guarantee you, if you went through these, the midterm would have been snap. Just saying. So I don't just give you these just for you to skip over. And I will tell you now, the final is very, very similar to the midterm. So you have an idea. Yes, and still has wordy questions. So I can't avoid that. So practice for each of the sections. And then we have 2 assignments this week. I think we have 2. Assignment 1 has 8 questions based on our little schema. Make sure you note your queries, and most of you have been doing a good job putting in your results set. Please continue to do the same thing. So that's assignment. Oh, we only have 1. I guess I took 1 out. I think we have 2 coming up though. And then we have our quiz. Wait, let me make sure. Yes. All right. So only 1 assignment. I thought I had 2 in here. I did have 2 at one point. I guess I felt sorry for you all. Decided to, oh, that should say Module 9 rubric. All right. So just 1 assignment and the quiz. Just want to change that. Save. All right. And that's it. Piece of cake, right? This is your recovery after the midterm. And y'all did so well. Maybe one point I'll have a little pop quiz and you get credit for I did that once before, right? I think I'm going to do that again in a couple weeks, and you get full credit for the quiz if you do well on the pop quiz. All right.
Mm-hmm.
Oh, wait a minute. I'm missing one section. I think I skipped the section in the assignment. Wait. Let me check one thing.
You don't have section 4.
I don't have section 4 in there. Maybe that's why. I decided that it's not useful. I'll let you know if I just skipped it. But for now, you just have 1, 2, and 3 on the quiz, and not the exists in the last section, the with clause.
Mm-hmm.
Okay. All right. Any questions or comments?
No.
Okay, then. We made it through another evening together. Yeah, we literally only have 4 more weeks after this, and you do have the final project in the final. We're going to start talking about that next week. You know, what's required. It's basically building a nice little addition to your schema, and I'll talk about that. So no panic necessary. It's pretty straightforward, but I need to have you show your work and all this fun stuff. Okay. And that's it then. So I will see you all next week, right?
Yep.
All nice and cheery. And if you have any questions, don't be afraid to send me a Canvas message or whatever. And I promise I will respond.
All right.
Thank you.
Okay, thanks.
Thank
Thank
you.
you. Have a good night.
Yeah.
Have a good night. Thank you.